Hello, everybody. Here's your warm-up. Oh, let's can these ones. These are from yesterday. We left in a rush yesterday, so I didn't shut down my computer. Tut, tut, tut. Okay, there it is. Okay. All right. Convert those fractions into decimals. You're going to want to pause, and then we'll get this going. Okay. Can I get you guys in 5, 4, 3, 2, 1? Pretty standard, pretty run-of-the-mill. I appreciate you guys working together, and then honestly just getting ready to go with the rest of the day. I think you guys way deserve a point for that. Thanks so much, everybody. Okay, so let's talk about 1 and 11/16. Let's just talk about 1 and 11/16. So I wanted to convert 1 and 11/16 into a decimal. Maybe. 1 and 11/16 into a decimal. What would you do? Let's see here. David, what would you do? Oh, excuse me. Go ahead. Mm-hmm. Sure. 1 times 16 is 16 plus 11 is 27. So it's 27/16 as an improper fraction. Yeah, exactly. So you can do 27 divided by 16. 27 divided, that's 277. 27 divided by 16. And hey, presto, you get 1.6875. 1.6875. How many of us got 1.6875 for that guy? You guys doing okay? Cool. There's actually one other one I wanted to talk about. That was 217 90ths. No, -5. No, never mind. I didn't want to talk about any of those. Never mind. We're good. Hooray. All right, let's do it. It is the 41st day of school, guys. You know that 41 is the last Euler's lucky number. That is, if you take a number k and square it, subtract it, and then add 41, this will actually give you a prime number for every number between 0 and I think actually I have to say 40. 0 and 40, because if it's 41, that number would necessarily be divisible by 41, right? Yeah. Let's just try one. Let's just try one. This is kind of crazy. Give me a number between 0 and 40. Xander, give me a number between 0 and 40. 25. So if we do 25 squared minus 25 plus 41, we get 25 squared minus 25 plus 41. I get 641, which is a prime number. So I get, the one way we could prove it, like you and me, is that we could just go ahead and check all the factors. But let's go ahead and just see. Let's just go ahead and see. Because I only learned about this just today. So I'm just blinking you for a second, folks, because I'm going to pull up Wolfram Alpha, and I don't remember what's up on my screen. I just don't want it to be everybody's grades and stuff. Let's see here, Wolfram Alpha. There we go. Are you guys aware of Wolfram Alpha? It is a math supercomputer that you have access to. So, yeah, this is connected to a math supercomputer, and you can just ask it. What was that number? 631? 641. Is 641 prime? Yes, it is. Yes, it is. Yes, it is. So any number between 0 and 40, because 41, and the reason 41 wouldn't work, that's why I had to change it, is because if you think about it, if I had 41 squared minus 41 plus 41, what's negative 41 plus 41? 0. That leaves me with 41 squared, which, yeah, there's no way that could be prime because it's divisible by 41. Anyway, also, it's International, no, it's not International Necktie Day. That was yesterday. It's PB&J Day. Yay! Do you guys know what that stands for? No. No. Guys. What? That doesn't even make sense. No. It's World Pediatric Bone and Joint Day. It's World Pediatric Bone and Joint Day. Duh. All right. Let's see here, guys. What's our first essential question? And I would love to get that from, nope, nope, empty seats, empty seats. I am drawing empty seats. Oh, hooray, Thomas, save us. Let's hear Thomas. Yeah. How do we deal with equations with an exponent in them? Jeopardy! Songs featuring a number. Will you still need me? Will you still feed me? Asks Paul McCartney out loud in this Beatles classic. William. When I'm 64 is the correct answer. And then insects, that's a fly. That's a fly. A yucky fly. All right. Let's get to it, guys. Underneath all this, got a pencil? Absolutely. Today we're going to talk about equations with exponents. And before we begin, I would like to have a word with you guys. I have to do this every year. With my Math 8 classes and even my Math 8 honors classes, I don't really have to do this. But with 7-8 compacted, I really do. Some of you guys already know the shortcut. Like, we're going to do some work here, and some of you guys already know the shortcut. But here's what I want you to do. If you know the shortcut, I welcome you to use it. But I want you to think about it like this. It's all like when I'm teaching this class, it's almost like I'm teaching you guys how to cross a river. That's kind of how I feel it, right? Like when you, how many of us have crossed a river, like a river before? Is it easy or is it hard? Could someone tell me why it's hard? Why is that hard? Why is that hard? William, why is that hard? Yeah, exactly. So if I'm teaching you how to cross a river and everyone's kind of stumbling and falling in the water and I'm helping them up and I'm like, this is how we learn. And then someone else is like, hey guys, I found a bridge. And everyone gets out of the river and goes and uses the bridge. Did we really learn what we were supposed to learn? No, I just got a little wet, right? So if you know the shortcut, I welcome you to use it, but I want you to keep it to yourself. Does that make sense, guys? If you know where the bridge is, just sneak off and use it if you really want to, okay? But for the rest of us, let's let them discover, let's let everyone discover what's happening here. Okay. I want to talk to you guys about a square. Got a pencil? Absolutely. I want to draw a square. Yeah, that's a square right there. It is a rectangle. But all squares are rectangles. And guys, I know the way that my screen is, it makes it look a little bit ski-wampus. But if you're not in agreement, here's the thing. When you're looking at a picture in math, don't necessarily follow what it looks like, follow the labels. And if I put those little hash marks on there, I'm telling you that all those sides are the same. Also, I told you it's a square, so we're going to assume it's a square. Now, if that square is 4.8 meters across, can you guys tell me the area of that square? When I say teach, I want you to say, okay, tell me the area of that square. Teach! Okay, come on up. Oops, so sorry. In 5, 4, 3, 2, 1. Well, we're not there just yet. Okay, let's see here. Can I get a little bit of help? Oh, all right, bug those guys. Ethan, what is the area of that square there? 23.04 meters squared specifically. How did you get that? Beautiful. So here's what we did was we said 4.8 meters times 4.8 meters equals, if you multiply two 4.8s, that's 23.04, and you do meters times meters, those just act like variables, and that would be meters squared. I think I actually heard Ethan also say 4.8 meters squared like this, which is the same thing, right? Because that's just that thing multiplied by itself. Okay. Let's draw a cube. Got a pencil? So if you're drawing a cube, you start with a square. Some of us might not feel comfortable with drawing a cube. Some of us might not feel comfortable with drawing a cube. Some of us might not feel comfortable drawing a cube. Come on. And how you make it look like a cube is that you give it 3 whiskers. And the trick is to make those whiskers the same length and go in the same direction. Make it so they're parallel. Come on, buddy. Work with me here. There you go. It's going to be a long day. It's a good thing I didn't plan on doing the self-assessment today. They already fixed that? Close enough. Okay. I did the best I could. Oh, yeah, I got to flip this over. There's no self-assessment for you guys. But there is for these guys. Wait, was that for because my 7 honors has homework or because you guys don't? Okay. Both. Yeah, there it is. Okay. Okay. Now, guys, I know that doesn't look like a cube because I look like a terrible Picasso, but I said it's a cube, so we're going to assume it's a cube. What if I told you that those side lengths were 8 kilometers? Yeah, 8 kilometers. What is the volume of that cube? Give it a try, and here we go. That's a huge cube. Teach. That's a huge cube. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1. Andy, what is the volume of that cube? Yeah, 512 kilometers cubed. How did you get that? Yeah, 8 kilometers to the 3rd power, which is 8 kilometers times 8 kilometers times 8 kilometers. Cool. How do you think Al-Khwarizmi would see these? You guys remember Al-Khwarizmi? No. Al-Khwarizmi, he was the guy who talked about, he was the inventor of algebra. He's the one who talked about these in terms of words. So if I have a square, and this is its side length, can you write an equation, Al-Khwarizmi style, that tells you what the area of that square is based on its side length? And can you write an Al-Khwarizmi style equation saying what the volume of the cube is? The volume of the cube is based on its, do you guys remember, it's not actually called a side length when it's 3-dimensional. Do you remember what it's called? Edge length. Very good. Excellent. Good job, Ethan. This is edge length. I know it. And now it's disappeared. Come back to me, cube. There we go. So go ahead, guys. I want you to write an equation, an Al-Khwarizmi style equation that we'll shorten in a moment, that gives us the area of a square and the volume of a cube based on its side length and its edge length. Give it a shot, and here we go. Teach, teach, teach! How's it going, Isla? Painful. Oh, hold on. That's how the Greeks would do it. That's how the Greeks would do it. The Al-Khwarizmi would say something times something equals something. He had multiplication signs and equal signs. You got it the Greek way. You got it the Greek way. Yeah, that's how the Greeks would say it. That was what Al-Khwarizmi sought to fix. Okay. Can I get you back up here in 5, 4, 3, 2, 1? So I actually wrote down what the Greeks did, where the Greeks would say the area of a square is equal to the product of its side length and itself. And then the volume of a cube is equal to the product of the edge length and the edge length and the product of that result and the edge length again. And it's kind of a nightmare, right? So how would Al-Khwarizmi write it? Side length times side length equals area. That's exactly what he would say. And then what would he say about the volume? Thomas, what would he say about the volume? Oh, excellent. Edge length cubed equals volume. I completely agree. So let's clean these up a little bit because I don't want to have to write that all the time. I'm going to call side length L. So we can say L times L equals A. But I can actually simplify that. What could L times L be simplified? Do you just say it? L squared, yes. 2L would be L plus L. L times L would be L squared. And then edge length, I'm going to use that with a D. D cubed equals V. Because E is reserved. You actually can't use this as a variable. Because it's not a variable, it's a number. Yeah, it's about 2.718. 2.71813, I think. Anyway, I don't have a lot of E memorized. But E's a number. You actually can't use lowercase e as a variable. That's not allowed. I know. Capital E's fine. Capital E's fine. All right. So here's the point. Let's say I gave you a square. Let's see here. What if I told you that this square had an area of 196 feet squared? When I say teach, I want you to say, okay, talk to each other about what do you think? What would the side length of that square be? By the way, how many of you already know the shortcut that I'm talking about? Cool, you're welcome to use it, but do keep it to yourselves. If you don't know the shortcut, what do you think? How are we going to cross this river? How can I find this out? Because can someone tell me what it is I'm really asking about this? What am I actually asking about this? What do I want to know? What do you think, James? It's true. I'm saying what number times itself is 196? So go ahead, see if you can figure it out. Teach. Which one? Oh, beg your pardon. It's like, what wouldn't work? I'm talking to Maya, sir. Someone knows the shortcut. There's another way to do it. It's on there, but I'm not going to show you how to do that just yet. That's right. That's the idea. Okay. Can I get you back up here in 5, 4, 3, 2, 1? I know that some of you guys already know the shortcut. Now that we actually did that, how many of us are like, oh wait, I do know the shortcut? Cool. Guys, if you don't know the shortcut, this is how they did it back in the day. Isaac, we'd have no idea what side length this is, so why don't you take a wild guess? If I just said, I've got a square, it's 196 feet squared, what do you think its side length might be? What's your just knee-jerk reaction? What do you think it might be? Then just tell me a number. 3. Well, that's okay. Hey, he told me a number. So we're going to check. Is 3 squared 196? Nope. Is that too low or too high? It's too low, so we got to guess again. Isaac, guess higher than 3. 7 squared. That's 77 squared. 7 squared is 49. Keep going. 20 squared is 400.
Oh.
That's too high.
16.
16 squared is 256. Too high. 14 squared is 196. So the side length must be 14 feet. That's exactly right. That's exactly right. I'm going to tell you a story that is actually true. That is actually true. We have records of this occurring, which I think is amazing. Oh, actually, first, before I do, though, I want you guys to notice that we actually just solved an equation, whether we know it or not. We said the side length squared is equal to 196, and we did something and found out that L is equal to 14. That just happened. We solved that equation, but we need to figure out what on earth we did to do that. So, let's see here. Let us talk about the oracle. The oracle will respond to exactly one question. Oh, why only one?
Oh, I get it.
You blew it. You completely blew it.
Oh.
Yep. You screwed it up. All right. Guys, a Greek oracle once told a town that in order to survive, they would have to calculate the edge length of a cube that has doubled in volume. They would need to calculate the edge length of a cube that has doubled in volume. The original side length of the cube was 2 units, by the way. If the original, and they used way crazy units, but if the original side length was 2 units, what was the volume? You guys can just say it. 4 would be the area of a square. 8. So, because we know the volume of a cube is the side length cubed. Got a pencil? So we have this cube. Come on, friend. Hear me out. Hold it together, tablet. There we go. We have this cube, and we knew that its edge length was 2 units. That's what we knew. And so we knew that its volume was 8 units squared. It was this units cubed, excuse me. It was this like I don't remember. It was some kind of like a religious altar or something like that was shaped as a cube, and it was 2 units. And what they had to do is the oracle said you have to build an exact copy of it that is precisely double the volume. And they were like, can it be bigger than double? And the oracle said no. It has to be exactly double. So what would the volume of this be if it was exactly double the volume, everyone? The volume would be, ooh, not 64. That would be 8 times 8. It's exactly double the volume of this guy over here. 16. And they were like, sounds great. Well, okay, you guys tell me. What should we make this edge length if we want to have a volume of 16? Teach! Some of you know the shortcut. If you don't know how to type it in your calculator, I need the edge length, yes. Mm-hmm. What's that? Perfect. So do you know what the edge length of this guy is? Is it? Try. Oh, you already know it's not. Okay. What the heck? What? How dare I what? Teach you math? I dare because I'd lose my job if I didn't. If I just brought you in here and showed you Shrek, I'd get super fired. What? April Fool's Day. Just show Shrek. What would our essential question be? Okay. Can I get you back up here in 5, 4, 3, 2, 1? Some of you guys know the shortcut. Some of you guys actually know half of the shortcut and were deeply disappointed. Now, don't tell us what you put in your calculator, David, but tell us what your calculator spat out when you tried. 4, and you instantly knew that wasn't right, because 4 to the third power is not 16. 4 to the third power is not 16. It is 64, and that's trouble. That's trouble. So, I don't know. Was that too high or too low? Too high. So what's our next guess? 2? Okay. So we know it's not 2 because that was the original. Now it's 8. 3? That's too high. 2.5? Okay. 2.5. Oh, that wasn't bad. 2.75. Oh, yeah. 2.6. Nope. 2.52. You know what, though? Oracle wasn't having any of it. Oracle wasn't having any of it. 2.5 what? 2.51? Oh, not to the 33rd. That would have been bad. Ow. 2.515. Darn. 2.516. Nope. 2.517. Nope. 2.519. Nope. 2.5191. Nope. 2.5193. Nope. 2. Oh, that won't work. 2.5194. Nope. 2.5195. Nope. 2.5196. Nope. 2.5198. Nope. Now, guys, here's the thing. One of my deepest enemies is CheatGPT. I do not trust CheatGPT. I do not like CheatGPT. I do not call CheatGPT by its name. That is how little I respect CheatGPT. However, here's the thing. Computers are good at some things, right? That's the thing. Calculators are not smarter than you. Like, people often say, but my calculator said. Guys, your calculators are dumb. Like, your calculators are not good at math. You know what they are good at? They're good at boring, annoying calculations. Computers are really good at telling them, hey, you, do this. If it's too high, guess high. Guess lower. If it's too low, guess higher. What if I get it wrong again? Then do it again. What if I get it wrong again? Then just keep doing it until you get bored. I can't get bored. Then I guess do it forever. So we just need a way to ask it. We just need a way to ask it. Got a pencil? The equation for this is d to the third equals 16. We want to know what number multiplied 3 times is 16. And what we're going to do is we're going to use what's called a root. Write this down, guys. We're going to talk about the anatomy of a root. Not like in science class. Not like, these are the ones that suck up the water. Right? Anatomy of a root. A root looks like this. Big funky check mark. There's a big number on the inside. And that's the thing. How many of us actually have seen these before? Now, how many of us have seen the little number on the inside of the check mark before? Much fewer of us. But that is an essential part of the root. If we don't have it, it doesn't mean anything. Well, it does mean something, but we'll talk about that, okay? Now, each of these things have a name, so we're going to give them their proper names. Let's see here. This thing right here is called the radicand. The radicand, which does sound like something a Teenage Mutant Ninja Turtle would holler as they skateboarded down a mountain. Yeah, exactly. Actually, they all do. This thing right here is called the radix. Radix, dude! And the most tubular of them all is this one right here, my dudes, because it's called the index. Index, brother! Woo! Not really. Okay. So the root asks a question. The root asks this question. What number multiplied n times is a? What number multiplied n times is a? Well, it wouldn't be a because a times a wouldn't be equal to a unless a was what number? 1 or 0. 1 or 0. Very good. So it's not that. But what we can say is that d to the third minus 16 equals 16. I need to figure out what number multiplied 3 times is 16. So we would write that like this. The third root of 16. This says the third root of 16. Because a root is the opposite of an exponent. So how do I create balance? Yeah, Andy. I've got to do the same thing over here. If you want to undo a cube, you use a cube root. Because this says this number multiplied 3 times is 16. So we're going to say, what number multiplied 3 times is 16? That gets rid of that. And the reason that gets rid of that is because we're saying, what number multiplied 3 times is d multiplied 3 times? D. Yeah. What number multiplied 3 times is itself multiplied 3 times? Itself. So that side becomes a d. But now we have to ask our calculator about the third root of 16. And here's how you do it. First, you type the index. Boop. First, you type the index. And then you see this little part, right, this little button right here that says x root. If you hit second x root, it will pop the 3 into the index for you. And then we're going to take the third root of 16. And we get, look at that, 2.5198421. How close were we?
That's not what my calculator says.
That's not what yours says? Ooh.
Mine says
12? Oh! I know why yours says 12. Hold on, guys. There's a difference between this and this. Take a look. The 3 is on the outside of the root. That says 3 times the square root of 16. We'll talk about square roots in just a second. This says the third root of 16. So you have to hit the index, and then you hit the x root of 16. And it's 2.5198421. Does that really work? 2.5198421 to the third. Oopsies. Not 2 2s. Well, this guy seems to think so. But, I have something to tell you. It turns out that that's actually an approximation. Let's see here. Do I still have Wolfram? I do. So let's see here. I got to put this in here. 2.5198, 421 to the third. So if I actually ask Wolfram about that, look what we actually get. 16.000000400508 and so on. The thing is, guys, this is just an approximation because for reasons that I will talk about tomorrow, it turns out, guys, if how we could have done that game of like going up, like remember how we were like 2.5197, 2.5198, 2.5199, 2.51985. You remember that game we were playing? We could literally play that game forever, and we would never get to the end of this thing. We would never get to the end of this thing. So we're just going to have to do an approximation. I'm sorry, Oracle. We're going to have to do an approximation. So we'll call it about D is approximately 2.5. We'll round it to the nearest thousandth because that's what they do on the ACTs. If I round that 8 up, that 9 up, what does it become? 10, right? So it should be 2.52, about 2.52. Because 2.52 to the third power is pretty darn close. Hey, guys, you're in the way. Mr. McGowan, move. Thank you. All right. 16.003008. Again, the Oracle wasn't happy about it. So the Greek town had a heck of a time with this. So we got the edge length. P.S. This wound up being something they could not do, and every single person in that town died. I mean, eventually. It was 350 BCE, so it would be really surprising if any of them were still alive, really. Right? Like, of course they all died. It was thousands of years ago. Hi, Kale.
I put 16 to the power of 1/3 into my calculator, and that worked.
It does, but I can't talk about that until secondary math 1. That's when that first comes up. That's when that first comes up. I can't talk about that. Okay. Now, why this is helpful is that we can do things like, for example, got a pencil? Let's draw a square here. We're going to draw a square. I'm going to draw a square here. Watch me now. Hey. There, it's like a baseball diamond. It's like a baseball diamond. Yeah, you can make it like that. So a baseball diamond, guys, has 4 bases. And I actually don't know how far apart they are. Does anybody here? 20-something? You know what? Let's go ahead and call it 27 feet. Maybe it's just like a Little League baseball. I don't know. Let's just call it 27. What am I doing? Excuse me. I'm getting ahead of myself. Sorry, it's not 27 feet. What am I doing? I'm doing the wrong problem. You know what we're going to say? We're going to say it has an area of 90 feet squared. We're going to say it has an area of 90 feet squared. Now, we know how to use roots to fix that, right? If I want the edge length, let's ask our calculator, what number times itself is 90? Talk to each other, guys. Let me zoom out so you can actually see the whole process up here on the D. But go ahead, talk to each other. How can we ask our calculator what number multiplied by itself is 90? Teach.
Okay. 1.
1? Better not be 1. Ah! Okay. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Hey, I get it, guys. Here's the thing. I'm going to take the root of both sides, and some of you guys are just getting ahead of me and getting in a little bit of trouble doing it. What index belongs in that root, guys? Thank you. Yes, a 2. A 2 belongs in that index. Because I'm asking what number, if I take 2 of them and multiply, gives me 90. And I do that. And so that will get rid of that. That leaves me with L. Heads up, it's going to be approximately the second root of 90, about 9.4, we'll call it about 9.487. 9.487. Now, I'm going to tell you guys, I heard some people out there when I said what belongs in index, and a lot of people said none. Because when you have a blank root, we assume that the number there is 2. It's the world's only invisible 2. The world's only invisible 2. Can someone tell me why an invisible 1 is stupid in a root? Why would an invisible 1 be stupid in a root? Why would that be dumb? In fact, talk to each other. Why would an invisible 1 in a root index be funny? Teach! It means something. Okay, can I get you in 5, 4, 3, 2, 1? Why is the first root of 90 funny? James, why is the first root of 90 funny? Shh. Yeah, what number if I take one of them and multiply is 90? Oh, joy. Right? That's silly. That's silly. What? Yeah, exactly. It's like, what number if I take one of them is 90? 90. But this guy, if it's a blank root, it assumes there's a 2. Now, some of you got this as your answer. We're going to talk about what that answer means next week. For now, this button over here actually means give me a decimal approximation, and it will give you the same result. If you want your decimal approximation. We'll deal with 3 root 10 later, okay? But for now, we're looking for decimal approximations. Go home, let that sink in, and then we'll talk more about this tomorrow, okay? That's all I have time for. Thank you so much. You guys are winning the scoreboard game, and you also are in the lead with 7, so feel free to wander about the cabin, use your phones, whatever it is you need to be doing these last 5 minutes. We'll